Hi everyone, welcome back to the workshop, and it's repair time again, finally. First off, I have to apologise for the lack of videos in the past month or so. I've really been up to my eyes in production mode in the workshop, and if I just swing the camera around, you'll see exactly why. So I have actually been building just one or two PDV-S2 minis, as you can see here, and midway through assembly of them, and as you can see I've got all the PCBs all fully assembled, the main board and also the charge DC adapter board there. So I'm just at the point now of hooking up the main boards to start testing them. The charger boards, they're all tested, all working, and once I get the main boards working, I'll actually be soldering the two together and assembling them into their housings, etc. So there's still quite a lot of work to do, but I've got over the hill in terms of the part that's so time consuming, and that is the hand surface mount assembly of these boards here. I don't have a pick in place. Maybe I'll get one in the future, we'll wait and see. So all these were all hand assembled and reflowed in my own reflow oven. So anyway, back to the repair. And here it is. It's an Agilent, or actually it's an HP 34401A. It's a 6.5 digit multimeter. I bought it faulty off of eBay. Lowballed them with an offer and they accepted. So here it is. It did actually come without the smoked screen here, but I managed to pick up an Agilent branded one, although it's an HP meter itself, but they're identical inside and out otherwise, just to get it looking a little bit better. So the eBay ad said, when powered up, unit stays frozen on screen. Unit also has dead pixels. For this reason, we're selling it as is. So here it is. So the first thing I'm going to do is actually take the cover off. Let's take a look inside. I'm also going to take a look at the back. I think this was used in a country that has 110 volts as our main supply, so we'll need to convert it to 220/240 before I put power anywhere near it. But let's get the cover off and let's take a look inside first. Okay, so here we are inside of it. It does look to be fairly well intact and looks very, very clean inside. And on first inspection, nothing appears to be missing or damaged in any way. Certainly on this top side of the board there, the caps all look in fairly good order. A little bit of residue on this buzzer here that looks like it's probably had a sticker on the top of it or something like that maybe. And all the wiring looks intact, the transformer, and right through to the front panel down in here. So turning over the unit, same goes for the other side here, although there does seem to be a little bit of discoloration. If I just zoom in, there does seem to be a little bit of discoloration down here. That's where the power supply section is probably, and yeah, something's been heating up on the other side, but it doesn't look like it's been too bad, so it's probably nothing to worry about there. Okay, with everything intact, it looks like I can go ahead and convert the unit to 220/240 use, and then after that I will check the fuses. There's a fuse in the back beside the IEC connector, I think, and then I'll check the transformer by just measuring across the live and neutral on the back, make sure that's intact, and all going well, it should be able to attempt power up. So it's currently set to 120 volts there. It's a little bit hard to read, but there's a little indicator window there, and what we have to do is pop that out. There we go. Pull this out here, and we've got the fuse there, which looks to be intact, a nice anti-surge fuse there, and it's just a case of pulling this out here and rotating it round until the text lines up with the 240 volt. That should be that there. No, that's 100. That's at the bottom, got to be. Yeah, there we go. There we go, 240 volts through the little window. So with the fuse intact, I'll pop it back in. Right, let's put the switch on. It's in the on position there. Let's go across live and neutral. 140 ohms, that's fine. Perfect, open circuit when it's off. Let's go for power up. Okay, I've got mains connected at the back. Let's put the switch on, let's see what happens. I got a beep from the main board, but I've got absolutely nothing on the display. Nothing at all. Let's try again. Ah, we've got something this time. We've got a couple of pixels came up there. So the VFD is alive. We've just got nothing. So a single beep on power up at this moment I'm assuming's okay. It's not like we're getting a double beep or a triple beep error or anything like that. So I presume at the moment that the processor's okay. It's just a display issue. But first things first, we'll take the front panel off, we'll get down into the back of it and we'll start checking some voltages. So to get the front panel off, a lot of people have some trouble with these meters, and you actually have to release the front panel using this here. It's a special little catch which hooks under the front panel there and holds it in place. It holds it back towards the actual meter itself, and it's easier seen if you look at the one on the back actually. So the one at the back of the meter is identical to the one at the front, so I can demonstrate it on the rear one here. You've got the same little catch handle here, and what you're looking to do is unhook this here from the back panel, and you've got this little lever here, and what you actually have to do is push down on this little lever here, which seems counterintuitive because it's putting more force back into this catch here, but this little handle here has also got a catch under the back panel there. So what you actually have to do is push down on there, which releases the little catch there, and then at the same time lift it up, and you can see the little catch there, and then that releases the catch at the back. So I'll away and do that on the front one, and hopefully we can get the front panel off. Right, here it goes. This one's not so easy to get in about actually. Can't get your fingers. That's it. Oh, that's it. And there we go, and it's unhooked at the front. So with the little red catch removed, it actually gives enough room for the panel to flex, to move in at the sides there. Okay, with the push rod removed, that's crucial to getting the front panel off. I should be able to just lever this side here. Wow. A little bit stiff. There we go. That's it. And that's it. That's the front panel removed. The next thing I'm going to do is remove the display board from the front panel, just so that I can plug it in directly onto the main board there. Now to remove the board, it's only held in by a little clip here. It's actually the PCB's clip. You can see you've got this little tongue here, which is butted up against this plastic part here, which is part of the front panel. So all I've got to do is just lift up this bit of the PCB here, this tongue, and the whole board should slide that way and come out. So let's try that now. Just a little bit of pressure on the circuit board, just to lift it up above that tongue. There we go, and that's it. and that's the display board removed. And now hopefully the final bit of disassembly, I'm going to remove this aluminium cover here just so that I can get access to start measuring some voltages in and around the circuit board. And that's it lifted out. Okay, we're ready to do some probing around here. Got it all nicely set up, and looking at the circuit board and the schematics in the service manual, this architecture for the power supply side of things is very similar to the Agilent power supplies that I've repaired in some previous videos, in that there's a plus and minus 18 volt supply from the main board that comes up through this ribbon to the main display board here, and all the logic ICs on the actual front panel are minus 18 volt referenced, i.e. all the ground to all the ICs etc. are at minus 18 volts. And in order to get the 5 volt supply for the various ICs and the microcontroller etc. that's behind the display board, we actually produce a minus 13 volt supply. So minus 18 minus 5 volts is minus 13 volts. So relative to the ground on the main chassis, we would be measuring minus 13 volts, which would be the 5 volt supply to the ICs. I hope you get what I'm meaning there. But anyway, it's the same as the Agilent power supplies there. So I'm going to, first of all, I'm going to probe the main ribbon coming up and make sure I've got the plus and minus 18 volts coming up from the main board up to the display board. So first of all, put power on. Make sure it beeps. There we go. Nothing on the display, but like I said before, that's random, appears to be. We do have power on. So pin 1 on the ribbon is the ground, and pin 3 should be the plus 18 volt supply. And I'm getting about 16.4. That's okay. I've come across that before with these Agilent power supplies anyway, that the plus and minus 18 volts can actually be quite far off, but everything works fine. 1, 2, 3, 4, 5, 6, 7, and this here should be the minus 18 volt supply, and it's actually spot on, minus 18 volts. So for the moment we'll assume that the plus and minus 18 volts intact. But what I'm more interested in now is up on the display, have I got a 5 volt supply? Oh, wait a minute, got that wrong. There's not a 5 volt regulator on this board. There's actually two versions of this board here. This is the 34401 6.502, and there's also a 66501. This being the 66502, I believe it uses a 4.7 volt Zener diode in order to produce the 5 volts-ish supply. So in this particular version of the board, there's a large DIP package there, and that's a 4-bit microcontroller, which obviously handles all the comms between the main unit and the board itself, and also scanning the keypad etc. So measuring on the back of the board there, I think power's on at the moment. So this pin here, pin 21 of the microcontroller, that's a supply to the microcontroller, which is sitting at 16.2 volts, and the ground pin for the microcontroller over here is sitting at 11.1. There's your 5 volt difference. So that's the 5 volts across that IC. So I think from now on I'm probably going to move my ground pin here, which is referenced actually down on the main chassis. I'm going to move it to the ground pin on the microcontroller, and that's my 0 volts reference for the rest of this board. So there we go, that's it shifted. If I put power back on, I should now measure. Oops. There's my 5 volt supply across the microcontroller there. So that's fine. Okay, I'm probing around the display board. Power's on at the moment. I'm pointing at the scope, as you can see. And one thing I've come across, if I scope the plus 18 volt supply, as you can see, it's rather noisy. And the corresponding minus 18 volt supply, 4, 5, 6, here, is rock stable. So definitely the plus 18 volt supply looks very noisy, and that would certainly have an effect on the display board. So here's a schematic diagram, and this is where the plus and minus 18 volts get generated. There is an LM317 for the plus 18 volt supply here, and an LM337, the negative counterpart, for the minus 18 volt supply. And as you can see, there is a small tantalum capacitor C552, a 1 microfarad capacitor on the output of that LM317, and you've got a large electrolytic on the input. So I'm going to scope across the output capacitor there, small tantalum, and let's see what we get in the scope. Right, I'll just turn power back on. Should hear a beep. There it goes, and I'm going to go directly across that output capacitor there. And there we go, the plus 18 volt supply, as you can see, rather noisy. And I should be able to probe the corresponding tantalum for the negative supply. There it goes there. Not too bad. So I've removed the board from the multimeter, the main board, and I've removed the input cap to that LM317, and as you can see, there's a little bit of residue on the underside of the cap. This cap's measuring about 10 microfarads, so it looks like it's been venting, and there's some residue on here as well. It's been venting down onto the PCB, well hidden because it was actually sealed round, so I couldn't actually see it, and the top's nice and flat. So just goes to show that you never can be too sure of these large electrolytic capacitors. So I'm going to go ahead actually and recap all three of these ones here. I think this one's on the 5 volt supply for the main microcontrollers, etc. So I'm just going to go ahead and change that one as well. And there is actually another one on the board. If I just zoom out a bit, there's another one down here, this similar brand or same brand, so I'm going to go and change that one as well. So I'll come back when I've recapped and we'll see how we get on. Right, here we go. All four capacitors changed out for new ones, and I'm ready for a power up. Let's go for it. And we've got 2 beeps now. So, like I said earlier, I just thought that 1 beep was good to go, but maybe 2 beeps is good to go. So I'll go and connect up the display now, and let's see what happens there. So power off. Right, let's power up. Display is connected. That's looking good. Yes! I don't know if you can read that, but it's in the millivolts DC scale at the moment. I think there's some segments gone. Let me see if I can make that a little bit clearer for the camera. Let's see what's going on here. Okay, right, I'm just holding the PCB in the back of the front panel here. Let's see if I can see it a bit clearer. Yes, it is working, but the bottom row of segments right along the bottom there are not working. DC's missing it, the D of the DC's missing it, and of course all the digits as well. So wow, Okay, I'll play around. I think I'll go and resolder the joints onto the VFD in the back, and let's see if that brings them back to life. It's not exactly a bright display, I will say that. It could probably do with a new one, but we'll just try and see if we can't resurrect it. So for the moment I'll just go and see if I can resurrect that segment. Now it would be A, B, C, D, segment D on all of those digits there. Okay, there's a fairly good chance it's a VFD. I've got power up now, so I'm going to go into a good segment. I'm scoping the back of the display board there on the actual microcontroller, which has a segment drive on it, and if I go to pin 30, there is a segment drive there. I think that's segment A, and if I go on to the problem segment there, you can see it's pulsing away rather nicely as well, although it doesn't look like it's loaded up the same. If I compare it again, you can see it's a bit more rounded, a bit more noisy edges, and you might expect that as it's driving the actual VFD tube itself. And compare it again, and it just looks a little bit too square, as if it's open-ended to me. Now let me try another one. There's segment C, and yes, you can see it's a good bit noisier there and a bit more artifacts there as that segment drive's been loaded up, etc. And compare that again to segment D. It just looks far too clean. Well, it looks like the VFD's knackered. I did check continuity between the I/O pin on the microcontroller and the actual pin on the VFD for the segment D drive, and it is actually intact. So it looks like it's the actual VFD. I have actually tried pressing the display around and moving it around and flexing it as much as I can do in and around that pin on the VFD, and nothing brings it back to life, not even intermittently. So it looks like the VFD's knackered. So I can order a new one. They are for sale on eBay. What they're like and what sort of quality they are, how old they are, because I don't think any of them are brand new. I think they're used, not sure. So I'll go ahead and order one, but I think for now we'll just leave it at this here for a part 1, and I'll come back with a part 2 to replace the VFD, because that can be tricky in itself, getting it off properly, and we'll get this multimeter up and running again. Thanks for watching.